Hi guys, so today we're working on lesson 2.2, which is from page 34 if you have your workbook at home. But really this is because we took a break to really study and get into slope-intercept form. You guys really know some of this stuff. So I am just going to review some of the problems you'll see in this lesson. So first is reviewing this, which you guys already know. Slope is rise over run, right? And you know that the slope-intercept form is y equals mx plus b. So for this staircase, they've written a linear equation of y equals 2/3 x plus 20. Okay, so that is for this staircase. It's modeling how you can move up the stairs. So we're not going to worry too much about that. But we are going to start. So if you're following along, you want to see a picture that's better than what you can see on the screen. We are on page 36, and we're going to do A1 right now. So A1 says to use the data in each question to find the equation of the linear function. So you guys know how to do this. We did this a few weeks ago, right? So find the slope and y-intercept. So if I'm looking at number 1, I know my goal is to get this. So my first step is to find the slope. My second step is to find the y-intercept, right? So if I look up here, where does this thing cross? It crosses right here at the origin. Right? So it crosses when y equals 0. So I know my y-intercept is 0. Now let's look at the slope. So remember, for the slope, you want to make your life easier, you want to pick exactly where it crosses at an intersection. So there's a point, and then I'm going to use this point, 0, 0. So my slope is positive, right? Because it's going up. So it's going up 1, 2, 3. So 3 over, and it's going over 1, 2, 3 over 2. So my slope-intercept form is 3/2 x plus 0, which, remember, mathematicians simplify, so that's just 3/2 x. Okay, so that's number 1, remembering how to write slope-intercept form from a graph. Let me erase, this isn't mine. All right, so now we're going to move on to example in B, right? So this is on the next page. How do you find an equation for a linear function when you're given a table? Right, let's do that one. I have my paper ready here. So, y equals mx plus b. Okay, so we still need the same things. We need m, and we need the y-intercept. So m, we can use our slope formula. Remember this thing? y2 minus y1 over x2 minus x1. This is helpful here. So I need to pick 2 points. So you can look at this and pick whatever 2 points you want. So I'm going to stay away from the negative just to make my life easier, right? So what I'm going to do is I'm going to say, I'm going to use this point and this point, okay? So that means if I rewrite, I'm going to rewrite them like this, because that's helpful to me. So this first one is 1, 5, and the second one is 2, 7. You really want to challenge yourself, you can use the negative ones, right? It doesn't matter which points you pick, it will always work. But now I'm thinking I could also have used this 0, 3, and that would have been easy because I would have been subtracting the 0. But I'm just going to leave it for now. Okay, so remember, you label your points, x1, y1, x2, y2. And now I'm just going to go ahead and plug in. So when I plug it in here, I get y2 is 7 minus y1 is 5, x2 is 2, and x1 is 1. So when I subtract 7 minus 5 is 2, 2 minus 1 is 1, 2 over 1 just comes out to 2. So my slope is positive 2. All right, how am I going to get my y-intercept? Or my b? Well, remember, the y-intercept is when x equals 0. So do we know the y value of when x is 0? Yeah, they gave it to us right here. X is 0, so that means my y-intercept is 3. Okay, so now I can plug it in, and my equation is y equals 2x plus 3. Now I want to point out, they don't always give you where the x is equal to 0 and what the y is like. If you look at the second one, they don't. So how can you figure out where the y-intercept is? So I want to give you another way to do that. The other way you can do that is you can graph. So let me graph real quick. So when you do this, though, you have to make sure that you're somewhat precise. You could also use Desmos. That would be super precise if you put the points in using a table. But I'm just going to do this here. So -2, -1 would be here. -1, 1 would be up here. 0, 3 would be right here. 1, 5 would be up here. 2, 4, 5. And 2, 7 would be somewhere up here, right? So I could always sketch, and then you should use a ruler. And you can do a much better job than I can. That was a really bad ruler use. But you can use a ruler to connect all your points. And you can see there's where it crosses the y-axis at 3. But remember, you can always go to Desmos. So let me show you what that looks like. If you want to be extra precise, you could come to Desmos and you can insert a table and you could type in those points and then it would graph it for you and you could see where the line would actually cross. Okay, so those are your 2 points to figuring out B. So when you're given a table, you use the points to find the slope, and then you have to draw a graph or use what you know about the function to figure out where it crosses the y-axis. So those are the trickiest ones. And then the last thing we're going to do is C1. So we're skipping all of this stuff up here. We're just going to do this. So the points 4, 2 and -1, 7 lie on a line, okay? Let me cover this up for you so you guys don't get confused. Looking at this one. What is the slope of this line? Okay, well, we know that. Where'd my pen go? We know we can do this. Okay, y2. So if you want me to label it, I'm going to label it over here. So that's going to be 7 minus 2 over -1 minus 4. 7 minus 2 is 5. -1, take away 4 more is -5. 5 divided by -5 is -1. So slope is 1. So there's my answer to number 1. Okay? 2, find 2 more points on this line. How can I find 2 more points on this line? So here's what I could do. I could graph. So I know 4, 2, and -1, 7 are on this line. So let's go to 4, 2. 1, 2, 3, 4. I'm just going to draw as neatly as I can. 4, 2 is right here. There's one line, 1 point. I also know -1, 7 is on this line. So 7 is going to be really hard for me to draw. It's like going to be, I drew way too close to this. I'm going to use pink so you guys can see. It's like somewhere, -1, 7 is 1, 2, 3, 4, 5, 6. It's like somewhere up here. So those are my 2 points, right? You can do yours much more neatly and space it out. But all I did was plot those 2 points. So I need to find another point on this line. So what I would do, really you only need 1 point. So I know this point is here, right? 4, 2. So to find another point, I can use my slope. My slope is down 1 over 1, right here. Down 1 over 1, because it's negative. So you can see I'm getting all these new points. So I can use any of these to be my new point. And so I'm going to use this one. This point right here is 5, 1. So that's the point I'm going to use. This is my new point. You can have any answer you want. Really all you need to do is draw a point and then use the slope to find the new point. So pick a point. So I picked 4, 2, and then use the slope to get a new one. Down 1 over 1, down 1 over 1. Okay? Or you could draw the line and pull a point off of that, whatever is easiest for you. So it says to describe my method. So my method is I plotted 4, 2, and then used m equals -1, so my slope, to find a new point, 5, 1. All right, so that's our quick review of how to get things in slope-intercept form and use what we know to work backwards to find points, okay? So you get some practice with this today. See you guys next time.